computer.
Yeah.
And do you see the screen that we have right now?
Thank you, Elba. Great.
Yes. Do you have the screen of the welcome screen?
Yeah.
Okay, great. So I'm gonna let the participant enter.
Yes. Perfect. Let me hear. Yeah.
They are entering right now. Hi, welcome to our virtual Saturday Research Academy. This talk will be recorded. Hi, welcome to our Saturday Research Academy. This talk will be recorded. I'm Dr. Elba Sepulveda, and I will be the moderator of this activity today. Please remember to fill out the participant survey that will collect basic information about you and mentors, teachers, parents, or any general guest. We are collecting this information to make the report, and remember that this is something that we need just to have information about what is happening today here. Also, we are going to have the evaluation of the conference, and we will have Dr. Aratia, who will start, talking to you today and give you the welcome to this academy. Thank you so much for being here.
Great. Thank you very much, Dr. Sepulveda, and welcome to all the audience that we had today, especially our speaker, Dr. Claude Laguë, who is a professor from Canada. Yeah, he was a Fulbright visiting scholar to Puerto Rico a few years ago, and we met each other, and he has a very interesting career. And so he's going to give us an overview of engineering with respect to the COVID-19 pandemic. So that is very up to date. So thank you very much again, Dr. Claude Laguë, for being in this virtual conference. And so the floor is yours to start the talk.
Thank you very much, Dr. Aratia. It's a pleasure to be here virtually this morning, and I'm speaking to you from Canada. So as you can see from the background, the weather in Canada is a little bit different than than what nice weather you have, because I was in Puerto Rico actually back in 2017 at about the same time, late February, and I remember the nice weather that you have at this time of the year. For us, it's we're getting out of the winter slowly but surely. But as I was telling Dr. Aratia earlier this morning, I went out to walk my dog this morning, and the temperature was minus 15 degrees centigrade without the wind chill. So it made for you actually wake up when you when you go outside by this kind of weather. So I'm a professor, as one mentioned. I'm a professor in the Faculty of Engineering at the University of Ottawa, and for the last 2 years I've been very actively involved in our efforts at the University of Ottawa to limit the negative impacts of the COVID-19 pandemic on our activities. And I thought that it would be appropriate, given that I am an engineer, just to draw a parallel between basically how can engineers contribute to our efforts against COVID-19, the COVID-19 pandemic. So there's a few things that I want to address with you this morning. First one, obviously, for those of you who are less familiar with engineering, so what is engineering? What do engineers do? And then we'll move on to other topics during the next few minutes. So I'd be interested, maybe in try to break the ice, that you reflect for those of you who already have an idea about what is engineering and what do engineers do. So I'm not sure if there are people who would not sure if there's a provision for you to basically either speak or write in the chat, but if you have any ideas about what is engineering, what do engineers do, it'd be interesting I'd be interested to see or to hear them, because obviously I know that for many people, engineering is not a very well-known profession. It's not something that is as prevalent in our daily life as a medical doctor, for example, or a dentist, or a vet if you have a pet, or an accountant, basically if you have to deal with financial stuff, which most of us have to. So engineering is a bit more remote from our day-to-day lives for most of us. So maybe at the end, when we have the discussion period, we'll be able to exchange a bit more on that. So what is engineering? Well, if you look at Latin, basically, which is a language that is at the root of many of our modern languages, including French and English. By the way, I'm a French Canadian, so my first language is actually French, not English. So if you look in Latin, engineare, it means to create. And basically, those two words capture the essence of engineering. If you look at the definition, there are many definitions of engineering, but one that I find very telling because it's short and it basically tells what engineering is all about. So engineering is that application of science as well as other disciplines, not just science, the application of science to the optimum conversion of the resources of nature to the use of humankind. So basically, we're trying to make use of the resources that nature is providing to us basically to improve the quality of life of people, provide them with food, with clothing, with water, with sanitation, and also, as we're going to discuss a bit later, means to fight against pandemics like the COVID-19 pandemic. So what do engineers do? Well, if we go back to the Latin root, create, basically engineers, they build, they create, they design, they develop, they fabricate, they implement, they improve. All action words, all action verbs. So basically engineers do things, they do stuff, they do things, and they provide people in society with acceptable, economical, effective, efficient, reliable, safe, sustainable solutions to practical problems. And examples of practical problems, well, there are very, very many examples, but I took two very simple examples about which we can all relate. So if you want to go from point A to point B, well, obviously you can walk, but if points A and B are remote from one another, well, you'll need some mean of transportation. So either you're gonna go by land, you can go below land, subway, for example. You can go on water, or you can go below water using submarines. You can go through the air, different means, obviously airplanes, but there are air vehicles that exist. And more, we also traveling in outer space. So we bring people to different places outside of the boundaries of our planet. Another simple example is how can I see and talk to someone who is in the house next door? Well, that's fairly easy. As we're doing this morning, I'm in another country and we're talking and we're seeing one another because there's technology that have been developed by engineers basically to allow that to happen. And probably in the future, we'll have people going to other planets. I mean, we already have exploration vehicles on Mars, for example. So at some point, they're probably going to be humans also. And we're going to be able to talk and to see them on another planet because we're going to have the technology to do it. And the technology will have been developed by engineers. So there are all kinds of engineers. My own background is agricultural engineering. So I'm an engineer basically who apply engineering principles and practice to solve problems that relate to the production of food. And more specifically, my field of application is in crops. So I'm looking at how we can build machines, equipment, and use those machines and equipment to grow, harvest, and protect crops against pests, for example. And I'm going to go a bit more detail about that later. But there's all kinds of other engineers. There are automotive engineers, there's aerospace engineers, there's communication engineers, food engineers, industrial engineers, ocean engineers, shipbuilding, software, water engineers, very important, basically to provide safe, potable water to communities. It's not something that was always there, but now with many billions of people on the planet, that's something that is obviously very important. So I talked a little bit about myself, but maybe just to give you a little bit more background. So who am I? Well, I'm a licensed engineer. So same in Canada, very similar than in the United States. If you want to practice engineering, you need to have a license. And the license basically will be delivered in the US, it's delivered by states. In Canada, the licenses are delivered by provinces. So there are 10 provinces and 3 territories in Canada. So each of them has a capability of allowing people to practice engineering. So myself, I can practice engineering in 2 provinces, my home province of Quebec and the province of Ontario, where the University of Ottawa is located. I mentioned at the beginning, my current day job is mostly to coordinate our campus reintegration activities at the University of Ottawa because as a result of the COVID-19 pandemic, I'm also responsible for continuing education and professional development activities in our Faculty of Engineering. And I'm also a professor in the Faculty of Engineering. So for example, I'm supervising right now students who are doing doctoral studies in engineering related to my field of specialization, agricultural equipment engineering. And I put at the bottom, I'm a volunteer warden, that we have a corporation in Canada that's fairly unique to Canada that administers what we call the ritual of the calling of an engineer, which is an obligation for that graduates of engineering programs take when they leave the university. And it's a little bit similar to the Hippocratic oath that the medical doctors take. So it's very similar. And Canadian engineers, they have a symbol. So we wear an iron ring on the little finger of our dominant hand. So that's one way for us Canadian engineers to basically recognize one another. So where do I come from? Well, why I became an agricultural engineer is mostly because I was raised on a farm. So if you want to Google map where I was born, I gave you the coordinates. So it's in the southeastern corner of the province of Quebec, not far from the US-Canada border. So we had, my family, we had a dairy and a grain farm, and that's where I was raised. A few pictures of me and my brother with a toy tractor, toy tricycle, myself, way too small to drive a tractor. And so that's where basically I got exposed to engineering. And why I became an engineer, well, as I mentioned, engineering impacts all aspects of our lives. And when you live on a farm and work on a farm, you realize that from a very young age, because you're exposed to all kinds of technology, whether it's a tractor, a combine harvester in the middle. My family was also involved in selling and servicing agricultural machinery. With selling and servicing John Deere equipment. So all that basically made me realize from a very young age that I was really curious about, well, how all these machines came to be, how were they designed, who was designing them, what kind of improvement could be made, and that's what made me decide to go to engineering school and do agricultural engineering. So what have I done since I became an engineer? Well, I've been, I studied, I did my undergraduate education at Université Laval, which is in Quebec City, in the province of Quebec. I did my bachelor and my master's there. Then I did a PhD at the University of California in Davis, so the west side of the North American continent. I have worked as a consulting engineer for a small consulting engineering company, but most of my career has been in academia. So I've been a professor at Université Laval, at the University of Saskatchewan, which is in the middle of the country in Canada, where it's even colder than here in Ontario and Quebec. And for the last 15 years, I've been at the University of Ottawa, which is in Ottawa, which is the capital city of our country. And as Dr. Horacio mentioned at the beginning, I was a Fulbright Canada Scholar 5 years ago. So between the fall of 2016, spring of 2017, I spent most of my time in California during that my Fulbright scholarship. My home base was actually my PhD alma mater at the University of California, Davis. But I also spent a few weeks in Puerto Rico, where I basically had the opportunity to present conferences to people there in San Juan. So I was invited by Dr. Horacio and made a talk. I presented a talk at 3 different universities on the 24th of February. So we're almost 5 years to the date. And my topic at that time was basically our entrepreneurial ecosystem at the University of Ottawa Faculty of Engineering. So what we do in terms of innovation, design, and entrepreneurship with our students in the Faculty of Engineering. So that was a very nice experience. It was the first time that I had the chance to visit Puerto Rico, and looking forward to return at some point whenever the COVID-19 pandemic is over and we're able to travel again. What have I done as an ag engineer? Well, I mentioned that my field of expertise is mostly on the agricultural machines, equipment, and systems that are that serve for crop production. I also do quite a bit of work in manure management. Manure obviously is, for some people, it's a waste product, but from a crop production perspective, it's also a very valuable input because it can be used as a fertilizer. So I've been involved in work dealing with storage, handling, and land application of manure so that we can recycle this valuable byproduct to reduce the dependence on chemical fertilizers. I'm also very interested about the environmental impact of agricultural activities and operation. I did quite a bit of work on greenhouse gas emissions mostly related to swine production, soil compaction, which is a very important problem, especially in countries where there's a lot of mechanization in agriculture. So the machines, obviously, they facilitate the work for farmers, but they also have adverse impact. And one of those adverse impacts is that they can compact the soil, and the compacted soil is less suitable for crop production. And obviously, energy use and efficiency. Agriculture is a very important user of energy. So anything we can do to reduce the quantity of energy and make energy use more efficient is a plus for not just for farmers, but for society in general. And I've also looked at the agricultural impact of non-agricultural activities. Especially, I was involved for a few years in overseeing the construction of a major natural gas pipeline and minimizing and mitigating the impacts of that project to reduce the impact on agricultural production. So that brings us to the main topic, which is COVID-19 and engineering. So I'm sure that we're all aware by now, 2 years, more than 2 years now, after the emergence of this disease, of what COVID-19 is. It's a respiratory disease that is caused by a coronavirus that was discovered in 2019, SARS-CoV-2 virus. This particular virus, like all viruses, it's a living organism that reproduces and evolves. So I think we're also all familiar with the term variants. So since the disease has appeared, there's been a number of variants. The latest that we have heard from was the Omicron variant that appeared at the end of 2021 and was very prevalent during the first weeks of 2022. And so for over the last two years, a little bit more, COVID-19 has spread all over the world. And that's, I guess, one result of the fact that we live in a very interconnected world. So people travel a lot, and viruses travel also with people. So the COVID virus has spread all over the world. It has infected at least 500 million people. And obviously we'll probably never have the accurate picture of how many people have been infected by the virus, and it continues to increase every day. And so far it has resulted in more than 5 million deaths. So it's obviously something that has had major impact all over the world. So we also know that there's been other pandemics before COVID-19, and we also know for a fact that there will be other pandemics after COVID-19. It's just part of nature. I mean, those viruses, they evolve, they appear, they evolve, and some of them are more susceptible than others to infect humans. But if you look back in history, I mean, I just put there I guess, some of the better known viruses that have appeared over the last few years, as well as in the centuries before. So the Ebola virus in the mid-2010s, the H1N1 influenza virus, HIV, obviously, about 40 years ago. HIV virus that basically is caused the AIDS pandemic. A number of influenza virus, early 1900, there was the polio, there was a flu in the late 1800s, yellow fever, Russian plague, the Black Death in the Middle Age in Europe, and in Greece in 430 BC, there was what was called the plague of Athens, and all those diseases were the result of viruses that infected population at the time. So how does humanity fight against COVID-19 or against viruses in general? Well, there's 4 steps that basically are necessary to fight against a disease like that. First, you need to know your enemy. So you need to identify the virus as well as its mutations, the variants. So that's something obviously that the initial identification of the virus didn't take very long. And now the mutations are also identified very rapidly. And they are identified by scientists, by medical researchers that are specializing in that kind of work. And then you also need to understand how it attacks and affects humans. So once you know your enemy, you have to basically understand what are his tactics in terms of attacking us as human beings. Once you understand the weapons of the enemy, then you can develop vaccines, you can develop treatments to minimize or mitigate the impacts of the virus on our health. And again, all these things, researchers obviously very much involved in identifying, understanding, and developing the vaccine and treatments. And then, because we know that the viruses, the SARS-CoV-2 virus, like any other viruses is not going to disappear. It's going to remain in the environment, and we're going to have to adapt, like we have adapted to other viruses in the past through vaccination and treatments. So we're gonna have to adapt to this continued presence of the virus and new variants that will probably continue to emerge in the years to come. So that gives you a picture of basically the strategy that we as humans are using to fight against this microscopic enemy. Which basically leads me to what I wanted to discuss with you this morning is, well, how do engineers contribute to this fight against COVID-19? And I've gone through the same 4 steps that I mentioned in the previous slide. So if you look at the first 2 steps, which are the identifying the virus and its variant, and then understanding how it attacks and affects human, well, obviously the work is done by medical researchers and scientists, but they use equipment, they use technology, and that's where engineers come into play, because the engineers, they actually design, they manufacture, they operate, they maintain, they repair, they improve, they upgrade, they recycle or reuse the equipment that medical researchers and scientists are using. Can be an electron microscope, for example. It can be isolation rooms where people can work in close proximity with the virus, but in rooms that are provided with systems that prevent the virus from escaping from that enclosed environment, and also protecting the people who work there. So the protective equipment that the people are wearing, the respirators, the clothing, the masks, the visors, well, all of these equipment have to be designed and fabricated and maintained and upgraded, and that's where basically engineers come into play. It's engineers basically who design the tools that the researchers and the scientists are using in identifying and understanding the COVID-19, the SARS-CoV-2 virus. Developing vaccines and treatments, that's also a very an area where there's a lot of engineering work, because obviously the researchers will develop the vaccine, they will develop the formulation for the vaccines or for the drugs that can be used to mitigate or reduce the negative impact of the disease. So they will provide the formulation for those vaccine and treatments. But then you need to mass produce the vaccine, you need to mass produce the medication. And that's where, again, engineers will come into play. They will source the materials that are required to do that. They will design and operate the manufacturing plants and processes where the vaccine and the drugs are actually produced. They will design and operate the transport, storage, and distribution system that are required. You may have heard that for some vaccines need to be maintained at very cold temperatures. In fact, temperatures even colder than what we experience here in Canada during the winter. And they need to be maintained at those temperatures throughout, basically between the manufacturing plant to the end users. So you need to have what we call in engineering term a chain of cold that is maintained throughout the entire process, so that the vaccine can maintain their efficacy when they are administered to people. The engineers will also be involved in designing and manufacturing the vaccine and drug administration tools. So the syringes and the needles that are used basically to administer the vaccine, these are all equipment that needs to be manufactured, packaged, distributed, so that they can be used by the end users. And more and more, we also pay a lot of attention to recycling, reusing, kind of the spent containers, the syringes, the needles, again, to minimize as much as possible the negative impacts on the environment. And finally, when it gets to adapting, or we hear more and more the phrase living with COVID, because we're going to have to learn to live with COVID. So how do engineers contribute to that? Well, again, all the protective equipment that we use, so the masks, the visors, protective clothing, well, all of that needs to be manufactured. It needs to be improved, upgraded, and again, recycled and reused as well. We need to adapt buildings and equipment. We know that one of the main mode of transmission of the SARS-CoV-2 virus is through the air. So everything that has to do with ventilation inside buildings, air filtration, to basically reduce the risk of viral particle to basically move from one person to another in the same room. These are very important, and these are things that engineers do. And also all the apps. I mean, you probably, I have an app on my phone that is basically coming from the Canadian government that's been around for almost 2 years already, that will basically tell me if I come in proximity with someone who has received a positive COVID-19 test. So that's basically a means to, again, allow us to kind of an early warning system to allow people to take appropriate steps if they know that they have been exposed or possibly exposed to someone who is contaminated with the virus. I thought that maybe one very specific example, because we know that a lot of people will go to hospitals because of COVID-19, because COVID-19 is a respiratory disease. Well, for some people who are affected by the most severe symptoms, they may require respiratory assistance while they're in hospital. So because they cannot breathe, basically breathe enough air on their own, so they need to have assisted breathing system, and that's what we call medical ventilators, medical respirators. So machines basically that are used to basically supplement the air that the people are normally breathing, so that they will be provided with sufficient oxygen to maintain their health. So all those machines, which are basically specialized ventilators, so a specialized form of a ventilator that you would use in a room basically to generate some air movement. Well, those ventilators, obviously, they're much more sophisticated and they are much more controllable because they can tune a precise amount of air that people will be provided with just to make sure that those people get sufficient amount of oxygen. And all of that, obviously, is the result of work done by engineers. So maybe as a few examples of the work that I've been doing as an engineer at a university, and I think you would, there's a lot of people who are doing the same kind of work that I've been doing at the University of Ottawa for the last 2 years. But I think that the fact that I bring, obviously I bring a university expertise because I've been in university for almost 30 years, well, more than 30 years actually. But coupled with the fact that I'm an engineer, that I understand basically how the technology in terms of development, procurement, recycling, reusing, and so on and so forth, how all of that function. This has allowed me to basically bring that expertise to the service of my university, so that we've been able, for example, to adjust continuously the level of in-person on-campus activities. So how much in-person teaching could we do? How much in-person research could we allow to happen? What kind also of non-academic activities could continue? There are some non-academic activities that have to continue in person. Building operation and maintenance is a great example. I mean, even though people are not physically present at the university, well, all our building system have to continue to operate, and some of that require the presence of people. And we need to make sure that the people who go to campus are basically provided with a safe environment. So basically what we've been doing over the last 2 years is continuously moving up and down with what we can do in person on campus according to the public health directive and guidelines that we're getting from our government authorities. One thing that may not have been as, I would say, as evident at the beginning was the need for IT equipment, all our information technology equipment. Students are studying from home, people are working from home, and they need to be able to communicate just like we're doing today. So today we are using the Zoom platform. There are other software that do the same thing, but all those software, they require equipment basically to operate, and they require also networks and communication networks so that we can communicate, the sound can communicate the image, the pictures between people so that they can continue to study or work effectively. So that's another example. And we also have means to kind of monitor the presence of the SARS-CoV-2 virus on campus. So we're doing wastewater monitoring. We're doing some high-touch surfaces monitoring in our buildings to ensure that to ensure that the level of virus presence on our campuses remains as low as possible. And we've been obviously procuring and deploying protective equipment and materials, so disinfectant, face masks, clothing, to our students, to our employees. Well, some people require very specialized protective equipment. We have students, for example, who work in hospitals, in clinical placements. So those people obviously need protective equipment that is quite different than what is required by someone who is working in an office. So basically, that brings me to the conclusion of my talk. And at this time, I would really enjoy entertaining questions coming from you. And I hope that I may have encouraged some of you to explore possibility of becoming an engineer. I just want to leave you on a quote. It's just 8 words, but I think 8 words that tell a lot about what are some of the key differences between engineering and science, because oftentimes we see science and engineering together, but these are 2 very different activities. Science is about knowing. So science tells us how the world works, and engineering is about doing. So actually doing something, using the knowledge that we have, the knowledge that science is providing us to make the world a better place for all of us. That's basically what we're all trying to achieve. And it's not just engineers, but obviously engineers, that's definitely something that is at the forefront of our thinking process. How can we use all that knowledge and the resources that nature is providing us to make the world a better place for all of us? Well, thank you very much.
Thank you very much, Dr. Claude Laguë, for your conference. I think that it was very wonderful to have you here, very informative, and we have learned about how crops are produced and how you as an engineer work on that field and how that impact the production of crops. And maybe this question may be a little bit silly, but do you know how the producers right now are doing any special treatment to the food that we are getting today from the supermarkets due to the COVID? I don't know, that may be very silly question, but
no, I don't. There's nothing at the beginning of the pandemic, when it was thought that the virus was able to survive for a long period of times on surfaces. There was quite a bit of work that was done in terms of, for example, disinfection of food packaging. especially the food packaging that you see in retail store. But I think we have scaled that back quite a bit now because we know that the virus doesn't survive very long on surfaces, and that the main mode of transmission of the virus is actually through the air, through either droplets or aerosols. That mostly how the COVID-19 virus is transmitted. So actually, engineers now are putting a lot more energy in improving everything that has to do with ventilation and air filtration inside buildings, just to make sure that there are as little as possible of those contaminated droplets and aerosols that could infect people.
Right, and based on that answer, right now, you know that our world has changed a lot. So what about the work that you are doing right now is affected by COVID? We want to know about what engineers were used to do before and what they are doing right now, like you.
Yeah, well, for me and the work that I do in let's say in agricultural machines and equipment, the impacts have been minimal because I mean it doesn't really. Well, they've been minimal, but in a sense, I think it's also accelerating the need for to apply the autonomous vehicle technologies to agriculture. So I think we've all heard about self-driving cars or self-driving trucks. Well, obviously, the same kind of work is done in agriculture. So you have self-driving tractors and self-driving harvesting machines. And I think there's probably been a little bit of incentive to accelerate that work again so that we can basically minimize the need for people to work in close proximity. I'm thinking about harvesting, for example, where many harvesting operations that are still done by manually can require people to work in close proximity. Well, obviously, if you can automate some of those operations and you need fewer people, then you reduce the risk at the same time of people contaminating one another. So it's kind of a side benefit. So there's probably been some acceleration of that work because of the COVID-19 pandemic. Yeah.
Okay. Thank you so much for your answers. Let's open the floor for more questions. You can write your questions on the chat, or you can raise your hand, or or just use the microphone to ask more questions. I know that Dr. Aratia, do you want to make or to ask any questions? You need to unmute yourself.
Okay. Yes, I had a question, but the student really and faculty, where they are able just to have the opportunity to ask questions to Dr. Laguë. So, yes. No questions. Wow.
No questions.
Wow.
Well, maybe one thing that I could, I know at the beginning I had asked people to think about what was their own, what were their own perspective about what is engineering and what do engineers do. So I don't know if there are some people who had a perception of engineering at the beginning, and the perception has changed after my presentation. So that'd be interesting to see, if to hear from people who have maybe seen their perception of engineering change because of some of the things that I discussed this morning.
Yeah, I think that was really interesting where you went through the process to see of the difference between a scientist and an engineer. I think that's interesting. But today you see those two things, because they are a combination. People who really do a lot of science and do a lot of, solutions, right? So you have to go probably across those two areas, pretty much. You see, in bioengineering, for instance, you had the evolution right, that you had the background in biology, but also you need the solution. You need to be tied to the solution, not to just get just an engineer.
Yeah.
Probably it happened really today with the medical profession. You see, they are highly, you see, with technology. Before it was just the body, but now you see how you really upgrade your body with technology. And that means that you had to be a biologist and also an engineer in terms of developing and also using the technology. I think that's what happened today.
Yeah.
And that's really interesting. You see, for me, it was an example. You see, I'm an electrical engineer, but doing a lot of stuff with biologists, students, and all this kind of stuff for the last 20 years. I had a lot of background, you see, between biology and engineering, okay, with devices and with the solutions and how to face, you see, the new discovery in the medical field. Because that's the acceleration. Today is a revolution in terms of development, because we do have, you see, MD, PhD. So we have people with the mentality to be a PhD, not an MD alone. Okay, just serving people. Okay, they want to make a solution for a bigger group of people. You see,
and another interesting thing or question about that is that we have right now a lot of people that are from different parts of the world participating in this conference. I want to ask you as a participant or our presenter, how different is the world that you are living today compared to the world that you were living before, about the crops and agriculture things that you see all over you? Do you want to participate?
Yeah.
Who want to participate and talk about your experience?
Yeah, I think we do have one student who is from Chile. Well, let me see, Felipe Herrera. Felipe, what do you think? Do you have any question? Yeah. Felipe, are you there?
I don't have questions.
You don't have questions? Are you?
You can write your ideas here on the chat. You can say, oh, it is different. It is the same. I see people outside more or less than before. What do you think about the world that we are living right now, based on the availability of the crops and things that you see at the supermarket?
Yeah, and also we have student here from Puerto Rico, Marisol. Marisol, you had any question? Yeah, because you see, Dr. Laguë, he gave us a it's interesting to be in the so these opportunities just go into engineer, not just going into engineer per se, but to bring, you see, when you already learned or are learning in biology into the engineer area. Yeah. Marisol, you have any question?
I do not have any questions. I believe he explained it very clearly. And I think, well, everything that the engineers do for us today and because of the pandemic is very necessary. And it's very a great step that we're taking, because this not only will it help us for taking on this pandemic, but like possible future pandemics.
Yeah.
All right, thank you very much. That's great.
Yeah, no, I think you're raising a very good point, Marisol, because I think we have learned a lot from this particular pandemic. Just thinking from a scientific perspective, the new mRNA vaccine technology that had been in development for probably 10 years before the pandemic, but it's really the COVID-19 pandemic that actually sped up the practical implementation. And that was both a scientific advancement and also an engineering advancement to ensure that we were able to manufacture those new kinds of vaccine, manufacture and distribute those new types of vaccines. So there's definitely been a major advancement on that front that has resulted from the pandemic, and that will obviously be very useful when the next pandemic, the next virus of concern comes along, and that will happen. We don't know when, but we know that it will happen at some point in the future.
Thanks, Dr. Laguë. I think it is yes, Laguë. And well, thank you so much for your participation. And let's continue with the participant survey and conference feedback links. I sent that on the chat, and I want to thank our sponsors, the Citizen Diplomacy Action Fund and the Scientific Caribbean Foundation, that without them we weren't able, to have these kind of activities. Also, our next presentation is going to be on March the 5th, 9 a.m. It's Dr. Rita Costa, who is going to be our conference participant or presenter. She's going to talk about resistance to diseases using genetics and genomics. Then, yes, do you want to say something, Dr. Aradia?
Go ahead.
Yes, I was just giving.
No, after.
Okay, and remember
Yes.
that we have here the verification of attendance. Thanks all for participating here. Please do a screenshot of the certificate of attendance of this talk. Remember to capture also the date and the time that you were here. And thank you so much for being so kind to be here and give this special conference to all the students. We have people from all over the world, and we really, really appreciate all you do for making our world better. And I will let you with Dr. Aradia now, that he wants to say something more. I don't know if, yes, he's here.
Thank you. Thank you very much for the opportunity. It was great.
Claude, thank you very much, Claude, for I'm not sure if we are connected. All right.
Right, and
Because the connectivity from here is unstable a little bit.
Yeah, that's
Claude,
the
thank you
joy
very
is,
much.
yeah,
you can say,
the joys of virtual conferences. Sometimes the technology is not always 100%.
But this is the weather. This is the
Yeah.
atmosphere. Because
Yeah.
it's trying to rain here in Puerto Rico, and when the rain is coming, you see the connection is not 100%. Yeah. So,
well, thank you so much for being here. I will stop recording. Dr. Laguë, you can stay with us for some minutes if you